Welcome to Beyond the Qubit. My guest of the day is the CEO of SoftQuantus, Roytman Piccoli. Roytman is an interesting guest because Roytman is in the intersection of cloud, quantum software, and enterprise. And what fascinates me is that Roytman he has a view on independent verification, operational fidelity, and real benchmarking, and he developed an auditing layer. And with that, he's a really interesting person to speak to. Roytman, can you give a 2 minute pitch in which you explain why SoftQuantus is interesting for investors?
Yes, SoftQuantus is a building of a control layer or orchestration layer that is the next generation of computing. You can imagine when the Microsoft and Linux in the past come from the hardware. The people don't have idea how to use the computing, the classical computer. They don't have idea how it could be so great for the future of the world. Actually, that we can see how the classical computer help with AI and all the technology and any field of finance, medicine, everything. We advance a lot. The software quantum is working the same way, but the quantum hardware to improve the enterprises fragmented providers that actually exist many hardware construction, but we have a unreliable execution for portability, and we have a limited traceability and high simulation costs for the quantum. Actually, we don't have one framework that solve and create one unified platform. And the quantum software quantum created this. We have actually one system that is called KCOS, that is a quantum OS from software quantum, where we have the execution, the control, the simulation, telemetry. We have the reliability, we have score, we have the auditability across the quantum computing and hybrid backends. In this case, it's agnostic. Any kind of hardware of the quantum computing could be set in the KCOS. In this matter, because the value is not just a stack, but we create a CRUD, not just thinking in the hardware, but we create a software layer that make advanced compute really governable, economic and practical, and we became that infrastructure layer for the future in the quantum computing. And above this, we are creating the Synapse X, that is one system of agents for orchestration layer, where he connected the AI, any kind of LLMs, with the quantum computing layers that we are creating. In this case, it's helping make the quantum computing, any kind of quantum computing, with the AI together, make best research and use case for any kind of company that want to invest in quantum computing now for the future.
First lesson that you learned in your career and youth is side hustling.
Exactly.
And you have very clear examples how you did that in the past, and I think it's a really powerful lesson.
Yes,
I think also it differentiates you from other people in the industry. There are a lot of people with a university background, really academic, but sometimes they don't know how to make a business.
Yes, exactly. And if you see the CEO from Palantir, he told in the era of AI, just two kind of people will survive. One kind of people is that people that follow, study, and all their life they are in science and study one thing in science and they follow that. And the other person is like me, a person that have TDAH, or the person that have like Richard Branson. We think out of the box. We cannot follow the rules. We are not a person that could stay in that thing and doing the same things like orchestration that we need to just do that. No, we are a person that think different. And this kind of way to think different that will bring the innovation for the world, because the measure of the information will be free in the future. And what we will need is people that really could see this gap, could really innovate it, but not crazy innovation, but really gaps that make sense. Makes sense, it's a little bit crazy, but it makes sense.
Can you explain the benefits of quantum technology?
The benefits I think exactly we can see the probabilities. Yeah? Let's tell we everything is based in calculation or simulation, benchmark, hybrid flows with the values. And your brain, actually, we have just 7 inputs. If you think more than 7 things in the same time, we cannot process. Your processor is not so fast. Actually, we have the computing or the classical compute that make us, make much more calculations and simulations that we can't. We can save information in the memory long term, and we can use that information for long term and make calculations based on that. The quantum computer will be the same, but in much more big and large scale of probabilities and simulate things that is out of your mind or out of your probability thinking, because we don't have that capacity of do this. We are just creativity. We are just passionate. We use your passion for follow something, but we are not so good with numbers and we understand how put big numbers and information in the past and present and the future together. And the quantum computer will be for this, will be for simulate and create beyond your universal mindset for the probabilities in the world.
A quantum computer, is it a real computer or is it a misleading metaphor?
Is a real computing because it's imagine one calculatrice or one calculation material. In this case, is a real computing, but not in the computer that we see actually that we use the interface for create videos. Could be in the future because basic everything is number. How we can use that will depend how the people will create the new ideas. But I see the the programmable computational systems actually is very different of physical constraints, and the behavior and the workload sustainability of the quantum computing is different. What I mean, the exact wide infrastructure layer matter, because actually we need a software that translate that intent of the reality of the verse of quantum systems to visual and how the people can interact and work with that. In this case, is a useful metaphor, yeah? That we can tell the quantum is a real computer, not just one idea that the people are trying to create. No.
Okay. Could you describe SoftQuantus? Yeah. Okay, could you give a short introduction?
Describe
Where do you focus on and what problems do you try to solve?
Yes, we are providing a layer above of the hardware. We are not doing hardware for the moment, but we are creating one orchestration system that schedule and simulate telemetry, communication with the quantum computing. We have the benchmark test with 100 qubits in the real quantum computing that make or bring 83% of better performance and faster results with the KCOS. Because this behind of KCOS is not just a software that communicates with a quantum computer. You have one algorithm, one system that born the quantum computer. We call it the core. Would be in my back there, but there is a Synapse X. Synapse X is the core, also use the core, the KCOS. But this core, it's one system that when I created, I thought, what is the big problem actually of the quantum computing? We are not binary, or in the quantum computer you cannot measure, because when you get a bit, you cannot tell if the bit is spin up, or spin down. If you look, will be one or another, but in reality, before spin up or spin down or make that measurement, he is something else, and that something else is anything. Or in this case, you put a probability of a ball. We have a sphere, But the sphere gives spin up, spin down. But in reality, the spin of the quantum it's around in any part of the ball of the sphere. But when we measure, he became one on another. This is the big mystery of the physics for the moment, but it's interesting to think in that, and exactly what the software quantus thought when born. And because this work your system, of course, is a patent technology, uh, actually in the patent, because this I don't tell actually how works in reality, because it's a patent, it's some idea, an invention. We don't open like this, but it's this, you know. We arrive with 83% benchmark, better than just send the algorithm directly for the quantum computer.
If we take one step back, you say,
Yeah.
okay, we are the operating system above the quantum hardware. What does it mean in practical terms? And why do hardware providers like a Google, IBM, IQM, QEra, or any other quantum computing company, why do they need an operating software system above the hardware?
In reality, the software quantus interact with any cloud. In this case, the companies can use the AWS or can use Google or Azure that already have clients that is a quantum computing that put was a vendors for their cloud for make this interaction with these hardwares in the backend. In reality, the cloud is a server of someone else hardware. In this case, the startups companies that start with quantum computing for researchers. Of course, they are doing their own cloud, or their own hardware. That is Google. It's they making their own hardware. Also, the Microsoft and who more IBM. IBM is a lot is strong, but is not Ion Q. They are doing other kind of hardware. Have many ways to create a bit, qubit, and different kind of companies in this sector. In the standard, don't have one standard how to do one hardware quantum, and is that race for the moment about hardware, which will be the best performance, more reliable, and we just measure.
Mm-hmm.
We just measure and we just use. We let them run for now,
And is
and
it
we
fair to
measure.
say that the measurement you can track the progress of all those platforms in how fast they're improving and you could be seen as an independent benchmark? Is that a fair assumption?
Exact is a fair assumption.
Okay. And then if we think about the power in the value chain,
Yes,
IBM, I think they want to operate their own software.
yes,
Google also. But to your point, if you are a company and if you want to have an independent verification, then it's good to have an independent party. Is that a good
exactly.
summary?
Exactly this. We have one program that is called KCOS program partner, where we can measure the backend of the quantum computing from the was independent company from the backends. In this case, could be any kind of backends. They want to make one approach how fidelity and how fidel and how accurate is their benchmark compared with us.
Yes. And the power that you have in the value chain is not because IQM, Google, and others per se say, okay, we want to use your software. It's more like that the independent companies who want to work with quantum computers say, now we need an independent source who can help us
Exact.
objectively to compare like for like. And
Exact.
okay, how does
For
this?
example, we have a consulting company. Let's say one consulting companies get okay. I want to just you make it the fidelity and the accuracy of the quantum computing and the gates. and measure the bits, how is the progress of them in everyday calibration in that qubit. I want to have the fidelities 99%. They tell is 99%, 99.9, 95, and 93. I want to be sure what they are telling is true, and but without they are soft, independent soft, and there enter also the quantum computer QCOS. We have this service.
One of your central claims is that QCOS can choose the best backend automatically. What
Exactly.
inputs actually drove that decision, and how does the routing materially improve outcomes?
Yes, the decision is driven by operational health, is a queue state of the backend, recent failures of the rates, and the backend availability, and the cost of the workload in this fit, and the quality indicators. And the quantum side that we can include like calibration, freshness, error rate of the topology of the qubit, and the circuit's sustainability. And we could do this also in simulation or GPU side. We can include the resource load and memory availability and latency and environment stability and the point that route and base and the objective of the job or the algorithm. And it's like this we take the driven decision for best backends automatically. It's called the re-ranking. I have one system already that make is a Python that make a re-ranking actually make already something like that.
Okay. You introduced DRR, a real-time reliability score. What exactly is being measured, and why should a user trust that score enough to let it block execution?
DRR is an intent of the execution that is a signal into a decision layer that include the backend health and all the information of the recent failures. Basically, is that we'll gather all the information of the queue conditions, the quality indication, the effect of the probability to obtain useful result is based in the core of the QCOS. We should trust not in the magic numbers or score, but we should explain and make the traceable way and measure where is come from that information or that telemetry and the policy thresholds. And because this became this DRR, that is the fit of the backend with the best performance for the best results when the person uses the algorithm in the quantum computing. And there come from the QCOS quality for the companies or people that will use the software quantus.
Can we, yeah, what is SoftQuant mission?
Mission. The mission is make the quantum computing useful today, or bring really one use case for any kind of user that want or need probabilities and calculations and the best performance with the quantum. We are creating one way also of not just use what the hardwares are doing or giving, but how we can have the best performance with one system that we call a hybrid, where we can orchestrate batches in different quantum computers in the same time for make the calculations more bigger. Instead, I use one quantum computer with 100 qubits. Why I don't use two quantum computing? And I send the same algorithm for the both. Was a different GPU or CPU. Let's tell use 100 qubits one GPU, and the other quantum computer was a second GPU for the same calculations, and exponential grow this. Of course, the people of physics and people of technical, they will tell it's impossible. We can't. because this and that. Why is impossible? Some years ago, we don't think a man thinks that is impossible.
Let me check if I understand what you say. So you say at the moment, one of the problems is if you scale the qubits, you can scale it up, more
Yes.
qubits per chip or per unit. You can do scale out, making clusters of qubit chips, and you can improve the physical to logical error correction ratio.
Exactly.
But what you're saying, you're not talking about that. It's not about
Yeah.
scaling the amount of qubit clusters, because that's really a hard thing to do. And at the moment, there's not a lot
Exactly.
of people good at that. Maybe in photonics quantum computer, that's better, because photonics, okay, that exists already at photons, and that they are easy to transport. But what you're saying is not that. You say I can combine a workload across multiple quantum computer hardware.
No, it's not that I can. Actually, SoftQuantus have already. It's called the QCOS network. QCOS network is basic what they do. Instead, he uses one quantum computing for send. He uses two backends, three backends. You can use multiple backends for performance. And it's designed how? We provided the backend abstraction. We provide the agnostic execution. In this case, we can use
Let's take
more.
one step back. What do you mean with backend?
Backend is the quantum QPU. It's a quantum computing.
Okay.
Backend is a hardware.
So let's say IBM, you use superconducting quantum computer.
Yeah. Let's put IBM IonQ
And
via Azure.
yeah.
You get from the Azure and you put IonQ and use the IBM backend. You make the QCS will handle the backend selection and job routing for the algorithm.
And is it then comparing the workloads or combining the workloads? Because that's a different thing.
Yes. In reality, it's combining.
Oh, wow.
Combining the workloads. Because as I work in the architecture of the classical computing, I thought why we can't physically what make it impossible.
Now, what I thought what was impossible is as soon as you measure it, the state, the superposition collapse, and also the entanglement. And then from probability, it becomes discrete. And
Yes,
and
but
then if and therefore it's really difficult to entangle two different quantum technologies. So how does it work? How do you do that? And how do you combine the workloads then? How do you split the workloads? Or
in reality, yes, exactly. Let's imagine we have some ways to do this. Imagine we have the workload. We have the QCOS. We will split this task in subtasks, and we'll route this in the piece to the backend QPU A and QPU B. And each backend execute and assign the job. Cryptography. When we make one cryptography in these jobs, and the QCOS will collect this information, normalize this, and bring the score back, and combine the result. In reality, we run 500 qubits in QPU A and 500 qubits in QPU B. And the QCOS will merge all the results. And the best results we select centrally. The idea is use the power was a cluster like GPUs. For example, actually many companies use the cluster of GPUs for send batches in different GPUs or cluster. But the quantum compute, like you told, the big problem is that is the measure of the qubit in the different workloads. The probability is going down, or the prediction is supposed to not work. But combined workloads as a QPU is letting the software or the QCOS split workload in the batches and sub problems. He creates sub problems, and route this piece in the most suitable backend for the result. First, he will consider this. He will consider which is the best for that workload in that exact moment, and aggregate the results and dividends and bring that score back. So imagine we have 100 evaluations in the key in the backend of IonQ, and we have 100 evaluations in IBM. And the QCS will gather that energy from the both and rank the results. That's called the re-ranking, and will best the best performance of them. But actually, the idea of put all the results was a big cluster. Like I have two big computers of 100 qubits here, 100 qubits here, and I want to merge and make 200 qubits. Actually, we don't have that, but we imagine that could be possible
in the future.
In the future, yeah.
Okay.
In reality, in the future, it's possible. But actually, doing this, we already have a parallel system that can bring a much more reliable return for the comps that need really, really good return for the quantum computing.
Okay, now thank you for clarifying.
Yeah.
Can you walk us through the basic building blocks of quant software? What does the technology exist of? And maybe can you start with the user interface layer? This is how a person interacts with the system. Do you use Python? I think you use Python, SDK, REST API,
Yeah.
Jupyter, Streamlit, Dash, Synapses, Natural Language Interface. Can you walk us through?
Yes.
What does it mean for the listeners that are not used with those things, and why does it matter?
In reality, we start to create APIs because it's much more easy for run tests. API. We create one script, we create one algorithm, and we can test the backends much more fast. The APIs is basically this, it's just a call, is one interface programming language that the computing can run much more fast. We thought we have one UI or where we need to click a button, but we have just one script of one test and we have the results back. And we started doing this because much more easy to create one architecture. Normally, all the big tech actually create architecture like this with the backends in the APIs and connect this backend with front end, and after can be useful for any people. The idea is this: is create ideas based on APIs and really work, have the benchmarks, result really work, and after that we created some OS that will be completely with new navigation systems that will really be used for any kind of people without the programming background.
Okay. What else do we need to know about the user interface? So you said, okay, we work with the APIs.
In reality, SoftQuantus actually we are looking for connect all these dots or these APIs or this use case in one system that the person can use in their compute. They just start up the system and they have all their backends. They can bring their backends and use the quantum computing simulations. And we have a new technology that is integrated with Synapse that is an agent system for researchers that they can create agents with the AI and use the language that they want. If they have their own endpoint, they can bring those for the inference. We don't do inference, but they can connect their endpoint of inference for use as an agent for exclusive information that they have trained their AI for use was a MCP. That's a protocol by agents that is used with the AI. And they can use the MCP of the SoftQuantus for use the APIs and SDKs for develop and also interact with the quantum computer if they want with agents.
Okay. And then we have the the QC OS score, and this is the engine of the system,
Yes.
and it includes the unified software layer, routing logic, and the backend selection,
Correct.
and circuit orchestration and scheduling. Can you explain us how does this work, and what is it? Why does it
Yes.
matter?
The KCOS is, like I told, is the part of is a soul of the project, where come from all the reality of the hardware. We can put this was a runtime of the classical computing, where have the interaction between the hardware and the classical bits, where we make all the conversion, all the exchanges between hardware and the classical. And there come from the negotiations between the hardware of quantum computing and the classical information.
Okay, and the intelligent router, and this is the part that decides, do we choose IBM or IonQ or Rigetti or D-Wave? How does it work, and what exactly
Uh,
is it?
in reality, the person can use this was a backend telemetry. They can use it for the best performance of job, the best objective, quality, and queue, and cost. Because before you run, you can see everything, the cost, quality, and which is the best fit for you in the moment. Because you run in IBM, the cost is much more less than you run in IonQ. You can save thousands of euro per month just for running the wrong backend, and you can have the same results in the other backends. It's like you are using your classical compute for do something that is just a calculation of 100 plus 200, and you are using GPUs for that. And the people do it because they just want the result, but the investors, they want to know why they want to do that, and what is the result and the cost for run that.
There are two other important building blocks of your technology: quantum lock and synapses X.
Mm.
Maybe first quantum lock. What is it?
Quantum lock is advanced system that want mix, not replace 100% the RCA, but you can use hybrid RCA and the quantum computing for generate keys, public keys and private keys, more secured. Just make a little replacement, not totally, because need much more infrastructure for replace all. But the client could generate already RSA key, or not RSA key, but a quantum key, private and public for use case.
Okay. Can you explain what synapses does?
Yes. SynapseX is AI, is a layer of AI or intelligence. In reality, we have two things that Synapse do it. One of the things is one intelligent AI for orchestration using the SoftQuantus. Imagine in the future we have many AIs, but we don't know which kind of AI will be better fit uh, for some results.
Mm-hmm.
SynapseX will do that using AIs and the quantum computing together. We will get the best fit or quality response benchmark, or the response of different backends of QPU and different AIs. In this case, the person can put like 3 AIs or 4 AIs and run one algorithm, and the system of KCOS will make one re-ranking. This re-ranking will give the result, okay, use this and this. The SynapseX will make automatically using the best backend of quantum computing, the best AI for that answer or performance, or sometimes mixing the both can do it also. Getting the best result of one AI to another and mixing one answer or one result.
What is the idea about that, the recalibration? Because who does it at the moment? So if you're like IQM or if you're like D-Wave or Rigetti, who does do they do it internally, the calibration, and what exactly is it? And does the recalibration, does it matter for each quantum technology? So is the recalibration different for photonics quantum computing, neutral atoms, or superconducting?
For all, in reality, for all, recalibration is the process of returning and correcting the quantum computer physical parameters and maintain the accuracy of reliability. In reality, the measure of the company is making this manually, and needed some engineers in the background that will make the process. For we have actually the QPU, the process unit, is very high sensitive, and the behavior changes over time during the noise. The problem is the noise of the quantum computing and change with the temperature change, with the environment factors change. We have different noise, and this noise affect the QPU, and we need to keep recalibrating that operational system all the time. That operational system of that hardware. And why the recalibration actually is needed? Because we have always a drift over time of the qubits where the quantum QCOS enter. He can detect this drift and don't use that qubit for the moment. We have a 100 qubit, but 5 is not work well. We don't will use that 5. We have the calibration needed by the gate operational loss precision. We have the error measurement of error corrections that increase. We have environment noise that will affect the results that we spoke at. If you don't make this, the hardware don't make this recalibration, we will have the incorrect inputs. We will have a low fidelity. We have is not useful the computing from the quantum, because this actually is doing. For example, qubit frequencies. We have each qubit have operate a precise frequency, and with drifted will cause error correction, computation. Will be computation error. In this case, because this is so important, the error correction and this part of the work of the hardware, and the quantum actually companies, they want to do this better, but it's very hard. And we taught in that, and because all your system actually he can get this accuracy, and it's very powerful in reality. The core QCOS is very powerful because this I put was a OS. It's not just one script. It's something powerful. It's beyond of just one script that makes something, and could be useful as a core in any kind of the technology of quantum computing. Your idea is scale for the hardware in the future.
How do you differ from a classic, a quota computing, or a Qiskit?
In reality, the Qiskit and another is a language. Imagine you have a runtime in your compute, and above this you have the language. Where you can write programming, we can put new applications. The QCOS is not a language. It's a runtime of quantum computing. He make the execution of the hardware and the process of the converting that in the language use case.
But can you help the listeners understand where do you sit, and how do you sit above the Qiskit? Do you sit below classic? Where do you sit in the value chain? And how do you compare? So maybe you can explain how you compare versus Qiskit, and so to Qiskit you say, okay, we're above. So they run the gates and the
In reality, they are above. In reality, the Qiskit is more SDK, is a more is a software development kit that based in Python. Let's tell is more for developers to build and run quantum circuits. In this case, they will run and build that. Is more focused in programming and experimentation. In this case, this Synapse X, actually you can use the Qiskit in another language for make this kind of programming and make these runs in the KCOS through the backends. And KCOS is more operating layer infrastructure that use and manage orchestrate the governance and execution with the hardware. It's more for production, control, and scalability.
Okay. And Classic is more running the use cases.
Yes, they write a quantum algorithm, they simulate circuits, send the jobs to the quantum hardware, but don't have that operating layers between them. It's just like something raw. It's like let's tell the old language. COBOL. I forgot the old language that before we have one layer, like Microsoft or another technology that interact with the hardware, but the person need just prompt, and it's a Doom. I forgot now. Many languages is hard to remember. But the KCOS bring all that orchestration layers that could be created on other applications above.
Okay. Yeah. I want to come back to the problems that you solve for customers. In your pitch deck, you describe we can do vendor lock-in between quantum providers and tool chains. We can prevent. We have daily manual recalibration and hardware drift. No real-time signal for run reliability or fidelity. High cost of realistic quantum simulation. And no audit-ready or reproducible infrastructure for regulated industries. And quantum access remains too complex for non-expert users. Is that a good summary of the problems that you can solve?
Exactly, is that. The problems that we can actually solve is we not target a vendor lock. We actually have a manual complexity that is solved. Unstable run quality, solved. High simulation cost is solved. Lack of auditability is solved. Poor usability of non-experts is solved. In this case, and don't need to be expert for use. We reduce the operational friction that prevents advanced computing from being broadly used.
And which of those, the problems that you solve, is the highest demand for customers?
Is the quality and tools that could be reliable. Because the companies need some system that is reliable with the classical computing.
Can you explain this to me? I don't fully understand.
Actually, the main problem, we have a lot of fragmented technology in the quantum computing and different backends of quantum computing. And we don't have one system or one process that organize that for the real use case in the classical computing that really solve problems in the real world. We just running algorithms with just people that specialize specific in one field. And if someone don't understand, they are not sure what they are talking. It's you need to take a lot of effort or technical people for start to do something in the quantum. And the quantum compute KCOS solve that problem, that barrier. He create one layer that make easy for people that work in the classical computing connect with the quantum computing and run technology in that layer.
Is it fair to say, just checking if I understand it, is it fair to say that you're the independent benchmark there? That there's a lot of demand
Yeah,
for customers
exactly.
that they say we want to compare the backends, how they compare on quality and cost and reliability?
Your system make a run of algorithm, and he make the run in any kind of backends and bring back this information cryptography. Make a cryptography in the quantum computing, and the result in this case is untouchable, cannot be changed. So the logs that will go out from there will be precisely what the backend it's doing in that moment.
And your point is the performance of different quantum technologies or different quantum computers can differ over time as the calibration drifts, or if is that the reason why?
Exactly. So it's the moment because actually yesterday they are good, but now no.
Yeah, we're not used to that with classical computers. They're
Exactly.
stable, and that
They are stable. Yes, you can make more stable the system for run your workloads for really use, and you don't stay just with one quantum computing.
okay.
That is very good. You don't need to invest in one quantum computing and have a giant team for calibrate everything. You have open source like still like these backends for you just to work with your business. Focus what you do, not to be a quantum computing company.
Can we talk a little bit about competition? Who do you see as your biggest competitors?
Competition is a real competition is a mix of quantum hardware tools and chains, cloud providers, and their own quantum access layers, the internal enterprise teams that build the custom orchestration, classical alternatives that delay adoption and being good enough for short term. I think that is the real competitors.
Okay. And can you walk us through the barriers of entry for competition?
The barriers. I think the barriers for the competition is a little more about technical. The barriers in the data, system knowledge, orchestration, logic, reliable policy design, integration of deep cross backends is not trivial to build a useful control system plane like we are doing. That is work across heterogeneous systems and still produce the credibility of execution and decision, like we public make the public benchmarks about that. And this is very great from your side, and I think it is this, yeah.
Roytman, how hard is it to copy SoftQuantus?
Actually, many companies are trying, create and building libraries and SDKs or simulator or simple orchestration tools, include the big techs like Microsoft, but replicated the software Quantus has built the system of true enterprise grade quantum computing layer system like KissOS is completely different and challenge. Here's the most will be attempted but will fail because we are not just a deep system or technology, but we have a real world actually control expertise. The KCS is not another transpile or error mitigation wrapper in the quantum field, but we deliver really a closed loop of the system and calibration, real-time drift correction, prediction, noise availability of the hardware, and we put a lot of experience and hands-on in the production grade. And we bring this for the quantum jobs to the cross multiple vendors. We are not locked vendors. And in this case, I don't see companies doing that, don't have. And it's impossible because we have one patent that is a soul of the company that no one are talking about, and
Ah,
is yes, and born from that. And and when I talk with technical people or other companies, they want to know. They want to know what's it, how arrive at that. They want to understand how it's possible. But that is a part of the secret of the technology of the company. And we prove result with 73% fast calibration, 300% best MTBF, and we have a significant high qubit yield in the uptime. This is very powerful, for one company startup constructing the system that is agnostic, one abstraction plus governance layer. We are not just doing one thing. Just we are creating real neural control plane that is where the SoftQuantus is above, and we are above any other quantum computing backend actually. And we tested this software and this technology in the quantum computing, real quantum computing, that we expend a lot actually for development. Is 900,000 of investment for this research, and thousands of payment for the QPU and the hardware. It's not
Okay,
just the talk.
thank you for explaining. Roytman, could you walk me through the business momentum?
Yes, this is a big and great question because the business momentum is very important because actually we have a technology, but we are greedy for the clients or for customers for use this technology. And we make some partner with consulting companies that are in the very high top demand for the consulting companies for the quantum computing. Was AI agents or AI, how they can adopt the technology of AI in their company and solve the problems with the quantum and or AI. The consulting companies for the quantum computing also is doing the same for the quantum computing and helping the companies approach for the strategic way to invest in the quantum computing. And we are making the partners with these companies of consulting here in France and in Europe, where they will use your technology was a backend and systems for delivery information for their business clients. We just don't focus so much in contacting the companies directly, but the consulting company will bring this approach of delivery your technology during their presentation and how will be useful for themselves for make the tests of the backends and see with the client already have. Sometimes they have already backends. If they don't have, for show statistics or information about the quantum computing use case for their kind of algorithm that they could help their business.
Is it fair to say that the consultants will be your sales force? That they will help you to pitch to the network?
Yes, actually, yes. They will be the first sales force in the quantum computer QCOS, because actually the majority of companies don't know how to use. In reality, like agents, they don't know how to integrate it in their system. And sometimes they don't know how the business problems could be solved with quantum computing. And the consulting company will be there, for show this kind of approach and also for show using for them your technology and also use it for the client, the technology.
When do you expect to close a deal with them that they can
We
support
have
you?
already a deal. We have a deal already was consulting with the SoftQuantus. The deal actually is now they need present for the client. This will depend of the consulting company how they can handle the client and put the SoftQuantus in the use case for them. Possibly 1 month, next week. We have already use case in the real field technology that I have some company from that contact me for use case is a company of transport in Spain that is the big one of the biggest company there of the trains. They want to make best management use case with the transports in the city, and they send me one link that it's for me send a pitch how the SoftQuantus could solve their problem.